Hi, everybody. Let's bring up the chat. So I want to talk about the plan. I have a better idea of what the plan is. So for this semester, we're going to pick important topics. And for chapter 3, we want to talk about 3.7, 3.11, and then get into chapter 4. On that note, it helps me decide when to take our next test. So before we talk about the test, you have homework. On WebAssign right now, there's some homework due Saturday, 2.8, 3.1, 3.2, on the 3rd. Okay. Then next Saturday is 3.3, 3.4. We've covered 3.5 and I need to make homework for that. So I have a goal to finish it this week. So you have a week to work on it. And we're going to finish 3.6 today. So I'm probably going to add this to the homework list and just make some short assignments. But I think we're going to stop here when it comes to the next test. So probably going to have homework, but we'll wait on testing. So that's the homework. I feel confident about doing a quiz next week, so this will be quiz number 2. All right, I feel like I can have it up on Monday and do the next Monday. So from the 5th to the 12th. Just a few questions, not as long as the last quiz. And I'll write all of this up in an email to send out over the next few days, over the weekend. Okay, and the test. So we're taking 2 tests in a final. They have the same weights. We're just going to skip test number 3. So we're just delete it from the syllabus. Okay. So we'll pick up from where the last test left off, which I sort of forget where we were in chapter 2. And I think we'll go up to 3.5. Okay, so I forgot to write this due date. This due date is the following Saturday, which is the 10th. Okay, so homework, quiz, and your test. We're going to have this available on the 12th and then do a week later on the 19th. I think that's everything. And then we'll do some notes soon. So any questions or concerns? All right, so I have a comment that all of the meetings for the sections we've covered so far are in Canvas in the modules. So if you're looking for a past meeting, go to the modules section. And if we missed a meeting, I wrote that in the week, like wrote that date and that we missed class. So each week is updated with the modules that we do have, or sorry, each module is updated with the recordings that we have. Okay, so let's go into 3.6. Okay, so I will back up a little bit. We had an example to finish for the end of the section. Okay, the original problem looked like y, it's crazy, y equal to the root of 2 to the x, tangent 5x over x cubed times e to the 2x. Okay, then we used log rules. Well, actually, we took the natural log of both sides, applied some log rules, and we got to a new expression for y. Okay. And we wrote y equal to, let's see, got, well, we took the natural log and then ln of y is equal to 1/2 ln I actually brought the power down, x ln of 2. Then we had ln of the tangent of 5x. After that, subtract 3 ln of x. And minus 2x. Cool. Now we're going to do the derivative. And it's going to be implicit differentiation, so we're going to say implicitly. I didn't write it down, but I think I can spell it. Implicit. Cool. Okay, on this side, derivative of ln of y is 1 over y, but use the chain rule, so also multiply by the derivative of what's inside. So we've got a 1 over y times y prime. Then on the other side, we're doing the derivative. That 1/2 just sits there. And you know what? It's going to take up a lot of space. So we'll try to make it work. So this first part is a number times x. So the derivative here leaves that number, ln of 2. Cool. Ooh, this is a little messy. That's going to be 1 over the tangent of 5x multiply by the derivative of what's in there, and then multiply by the derivative of what's in there. Okay, we're gonna need space. Okay, so just rewriting that side. ln of 2, cool, add. So first layer of the chain rule will have 1 over tangent of 5x. Multiply by, actually when we multiply, we're just going to put that right there. Multiply it with 1 and get the derivative of tangent of 5x will be secant squared of 5x. Okay. And multiplying that with the derivative of what's inside of there. So derivative of 5x is 5. Cool. Subtract. 3 times the ln of x, which is 1 over x. And then derivative here is going to leave 2. And we can close it. Cool. I think this part's the only part we want to fix. And, or, you know, simplify, and then we're good. Well, we also need to multiply both sides by y. So let's go up. Here, do the multiply part first. Okay, rewriting ln of 2. All right, let's work on this. It's going to be 1 over cosine squared. It's this right here. I've got a 5 right there. And then it's tangents in the denominator. So instead of sine over cosine, we want a cosine over sine. Okay. Then this part and that part, we'll put in this area. Okay, almost done. This side, we've got y prime. Y prime. So we want to make sure everything on this side is back to the original variable, x. So instead of writing a y, we're going to put in all of that expression for y. So let's see, it'd be really nice to have a full room with a whiteboard, but squeeze this in. So it was that square root of 2 to the x tangent 5x. Over x cubed e to the 2x. Okay, so that's that part right there. Then times 1/2 times all of this. It looks kind of messy, but ln of 2 is sitting in there. We can clean this part up at least. So there's going to be a 5 sine x over cosine x. So 5 tangent 5x. Okay. Then minus 3 over x. Cool. done a wrong trig thing here. So we've got this, 1 over, that was cool. All right, I need to Google secant. Thought it was 1 over cosine, but it might be 1 over, let's see what happens. Sorry for rambling. Secant of x is 1 over cosine. Okay. So we'd have a 1 over cosine squared, which we did there. And then we had 1 over tangent of x, which would be a 1 over sine over cosine. So we flipped cosine and put it over sine. Oh, we flipped cosine and put it over sine. That's my problem right there. Okay. I put them next to each other, and that was a mistake. Okay, so 5 is over cosine times sine of 5x. Okay, so again, y times 1/2 times ln of 2 plus 5 over cosine 5x times sine 5x. Subtract 3 over x, subtract 2. And then that's the derivative. All right, so for 3.7, we'll see how far we can get. Okay, timer set. We'll try to do as many examples as possible. So we've reached applications of derivatives. I'm going to restate some things we've talked about before. First one is a position function is called s of t. Where t is time. All right, the velocity function is s prime of t. And we call it v of t. And the acceleration function is s double prime of t. A of t. So we're going to start an example, and I've got a lot of parts to the problem. So the position of an object is S of t. And then we'll get that. All right, we're going to have this equal to t over 1 plus t squared for t greater than or equal to 0. Find the velocity function and the acceleration function. So find v of t and a of t. So first derivative of a quotient rule. Let's call the top of the fraction f, and this will be g. So g times f prime, subtract f times g prime, and divide by g squared. So derivative of t is going to be 1. T times this derivative, 2t. Divide by the denominator squared. All right, I did simplify that, so we're going to have this numerator clean up, and then just leave the denominator how it is. Is 1 plus t squared minus 2, we'll just write down 1 add t squared minus 2t squared. And it's over this 1 add t squared. So negative t squared in the numerator, like 1 subtract t squared, put it over that. Denominator. Looks good to me. Next one. A of t is the second derivative. So now we're going to take the derivative of this. Let's call the top f, and then the bottom g. So g times f prime, subtract g prime times f, and then divide by g squared. O d high. So this derivative is going to be negative 2t. Oh no. This is First one is the velocity function. And we're working on this acceleration function. We just need more space. Low d high, subtract high d low. So 1 minus t squared times the derivative of the bottom. Oh, a chain rule. Okay, we're going to have this, everything in square brackets is the numerator. So we're subtracting 1 minus t squared times the derivative of what we're calling g. So 2 times 1 plus t squared to the power 1 multiplied by what's inside, the derivative of what's inside, which would be 2t. And then divide all this, which is the numerator. Like, I just couldn't make space for it. Everything here is over the denominator squared, which was 1 plus t squared squared. So we're going to square it again. Square again. Cool. Let's see. I did break everything out. So there's a negative 2t, and then we're going to expand this part right here. Times 1 plus 2t squared plus t to the 4th. Subtract. We'll FOIL this in a moment. So 1 minus t squared times 4t times 1 plus t squared. And everything is over 1 plus t squared to the 4th. All right, so that first part will distribute negative 2t. Let me see that I got everything down. Cool. That's where we are right now. Oh, oof. I could have factored out 1 plus t squared. It should work out anyway. All right, we're going to continue going with okay, I'm going to back up. We can continue working this out, but by expanding all of this, we can slow down and do scratch work. It's just going to take up a lot of space, but we'll just do the work on the side. Okay, well, let's work out this piece here. Okay, negative 2t minus 4t cubed minus 2t to the let's see, we're going to add. So it would be negative 2t, this would be 1 plus 2 is 3, and 1 plus 4 is 5. Still doing scratch work, but we're going to include this part right here. We're going to subtract this stuff. Which, I guess, no. It's going to take up a lot of room. So replacing that first part. -2t minus 4t cubed minus 2t to the fifth. Let's work on this. Okay, so well, remember that minus sign is sitting out front. 1 minus t squared times 4t plus 4t cubed. This, I've got cool, working this out. Okay, 4t. Add 4t cubed. Okay, subtract 4t cubed. And subtract 4t to the fifth. Okay, cool. I think we're going good so far, so we're placing this part in brackets for our scratch work. Plus 4t cubed minus 4t cubed, so we have a 0 right there, and then subtract 4t to the fifth. Okay, let's see if we can get to the answer. I'm going to distribute that minus sign, so it's a minus 4t and then a plus 4t to the fifth. I think that was a power of 5 right there. Yeah, it was. Okay, and combine like terms. Let's go ahead and write that denominator. Negative 2t and a negative 4t would be negative 6t. And then subtract 4t cubed. And then we have a positive 2t to the fifth. And let's see if that's correct. We could factor, okay, let's factor out 2t, and then it's a little off, it looks like. I think I might try this again. I'm gonna back up. I have a different answer written down, so we'll just do it again, double check, because I feel like this is missing, something got wrong. So if we kept going, and we have an extra term from what I've written down, so just in cases, I'm going to take a picture. And I'd like to do the problem again, just a different way. don't think that's quite right. Anyway. So instead of expanding the numerator, we're going to just factor it further and reach the answer, the correct answer. Okay. So I'm going to go to the part where we were doing the quotient rule. We had negative 2t times 1 plus t squared squared. Yeah, that was the bottom. Okay, subtract. Oh, I think I know what happened. I think my mistake was when I did the derivative of the denominator, I was supposed to use a chain rule, and I forgot that chain rule. Okay, we'll do it again. So it's low d high times high derivative of the denominator. So we're going to do 1 minus t squared times the derivative of 1 plus t squared squared. So we bring down 2. 1 plus t squared. And that's a power 1. And multiply by what's inside. Actually, I do remember doing this a little bit. So multiply by 2t. And, okay, that's good. Okay, and it was over 1 plus t squared to the 4th. Okay, so it was here where I started to multiply everything out, but instead we're going to factor out the 1 plus t squared to the front. And we're also going to factor out negative 2t. Just take out negative 2t and one of those factors, and it leaves 1 plus t squared. Subtract. Factoring that out. Wait, hang on. We're factoring that part out. So we have a 1 minus t squared. It needs to be there. Factoring out. We'll say this. Oh, there's an, let's see. If you're taking out negative 2t, I might change this sign here to positive. Let's do that part as our 2t. So there's a 2 left there. I think that's good. Good. Let's close it up after that. 1 plus t squared plus 2 plus 2 times 1 minus t squared. And it's over the denominator. Cool. Much better. So this part we're going to expand and then see. Oh, cool. I'm sorry. These are old notes and I'm just kind of remembering what I did. And I see that that's a common factor right there in the numerator and the denominator. So that's going to simplify as well. Yay. So let's reduce this down to 3. Negative 2t times stuff over 1 plus t squared to the power 3. Put that there. Okay. 1 plus t squared plus 2 minus 2t squared. So about 3 minus t squared in the brackets. That's the final answer. So mistakes happen. It's good to always double check. Never hurts to triple check, but also sometimes it's good to take a break and come back and try a problem another day. We got this one though. This is negative 2t times 3 minus t squared is over 1 plus t squared, which t squared, and then cubed. I'm gonna put it in like a square. Next part is to find the acceleration when the velocity is 0. So we're going to set v of t equal to 0 and then solve for t. All right. So v of t we already found. We're just putting that equal to 0. We had v of t as 1 minus t squared over 1 plus t squared squared. Multiply both sides by that denominator, and you're going to have 1 minus t squared equal to 0. And then solve for t. So I'm going to write this as a difference of squares. 1 minus t times 1 plus t equal to 0. So t is going to be plus or minus 1, and t is representing time, so you're going to choose that positive number. Okay, so for 1 second, or at t equal to 1 second, you have the velocity equal to 0. Okay, we are doing pretty good. We can continue through the problem to part C. Oh, cool. Let's see. Actually, I think we're going to start something new. I want to write down what displacement means, and then we're going to go into a new problem. So, displacement and distance traveled. Okay, so I'm going to make space in a sec. Velocity equal to 0, let that velocity function equal 0, solve for t, and remember that t represents time, so choose positive values for t. T is greater than or equal to 0. Displacement is the difference in the final position and the initial position. So the final spot subtracts the starting spot, and that's your displacement. Distance traveled is the total distance covered by the moving object. Okay, total distance covered by the moving object. Let's see, I'm just going to put object on the time interval. Okay, who has marks? Moving object on the time interval. Okay. We'll do an example for that later. Going to this other problem that we can go ahead and work on, where we have a bug moving along a straight line. It's moving along a line so that its position is S of t. Okay. S of t will be equal to t cubed subtract 9t squared, add 15t, and then add 10. All right, so that was t cubed minus 9t squared, add 15t, add 10. And that's in inches. Okay. First part, find v of t and a of t, the velocity and acceleration functions. Okay, this doesn't look so bad. So v of t is the derivative of s of t. And we'll work that out. S prime of t. We'll have 3t squared minus 18 t. Add 15, and you're done. It's going to be 0. Nice. S double prime of t is the acceleration function. So we'll do the derivative again. Take 6t and subtract 18. Nice. Okay. After that, we're going to find the initial position. And let's see, initial position, initial velocity, and initial acceleration, which in another class I'm doing, we call that your initial conditions. Okay. Position. Initial speed. Or velocity, but velocity just. And the initial acceleration. So all of these occur at the beginning when time is equal to 0. So we're going to let t equal 0. One more time. We're using t equal to 0. That's when time is equal to 0, and that's when we're starting to move. So when we start our starting position, our starting velocity, the acceleration we start at is all when the time is set equal to 0. Okay, back to S of t. Put in t equal to 0, and we're going to have an output of 10. The initial velocity. So you're putting 0 into the velocity function. And we'll get out, let me make sure I get this. 15. Cool, 15 inches per second. And the last part, put t equal to 0 into the acceleration function. And let's see. Initial acceleration. Would be, let's go to that function, put in 0, and you'd get negative 18 inches per second squared. Sweet. We can keep on going through this. So part C. When the velocity is, let me see, make sure. We'll ask, when is the bug at rest? Okay, we're resting, we're sitting when your velocity is equal to 0. Cool. We're going to let v of t equal 0, solve for t, and t needs to be greater than or equal to 0 since it's going to represent values of time. All right, where's our velocity function? 3t squared minus 18t plus 15. D plus 15. Okay. We're going to factor out 3, and then we're going to factor the rest. So after we take out 3, it leaves t squared, subtract 6t, add 5. Let's see, we could do this. I like the diamond problem for guessing and checking. You need two numbers that multiply to 5 and add to -6. -5 and -1. So let's do t minus 5 times t. Let me make sure I get this. Yeah, okay, -1 equal to 0. So there's two places where we're at rest, at t equals 5 and at t equals 1. Cool. Both of those are in seconds. Yay, we still have time. So we're going to go on to, when is the bug moving forward and backward? Forward or backward? Okay, for moving forward, we're going to have velocity greater than or equal to greater than 0, strictly greater than 0. Cool. V of t needs to be greater than 0. Moving backwards is when the velocity is less than 0. So what we'll do is take the velocity function, put it equal to, well, we're going to plot its critical points, which is where it's equal to 0, and then have test intervals. So here's what we're going to do. Sign chart. Okay, so here's values of t. T is greater than or equal to 0. Actually, I'm going to clean this up a little bit. So don't need this part here. Don't need any of this stuff on this side. Okay, we're at rest when t equals 1 and when t equals 5. Or velocity is equal to 0 at 1 and it's equal to 0 at 5. So our test intervals are from 0 to 1, between 1 and 5, and then past 5. Let's get that function up. So velocity function is v of t. wrote it as 3 times x minus 5 times x minus 1. Okay, first test interval. Put in a number like 1/2. 1/2 minus 5 is negative. 1/2 minus 1 is negative. Negative times a negative is positive. Between 0 and 1. Okay, between 1 and 5, put in something like 2. Okay, 2 minus 5 would be negative, and 2 minus 1 is positive, so this is a negative value. Okay, a number greater than 5, like 6. 6 minus 5 is positive. 6 minus 1 is positive. Positive times 3 is positive. Okay, v of t is greater than 0 between 0 and 1. So I wrote down we are moving forward from t equals 0 to t equals 1. Moving backward from t equals 1 to t equals 5. And forward again for t greater than 5. The last questions are, what is the displacement and what is the distance traveled? And I would like to draw a picture. I think we have time. We've got 6 minutes. So we're going to sketch it out first and find displacement, distance traveled. Okay, so technically this bug is moving forward and backward on a straight line, but we're going to have a little bit of space to represent, to see the time that's also happening while that motion occurs. Okay, so first we've got a bug, and its values for time are on the number line. All right, I've got negative 15. 0, 10, 17. That must be, sorry, one moment. Oh, I need to ask a little more. Okay, so we're going to put, we're going to talk about the first 8 seconds. So from t equals 0 to t equals 8. Okay, that way we have a place to stop at. All right, we're going to start when t equals 0, but when t equals 0, our position is at 10 inches. And let me see. So I'm not going to have everything fit on the graph, but let's keep on going. So we're a bug right here. It starts going along forward for the first 5 seconds, from 1 to t equals 5. So when t equals 5, or when t equals 1, you get out 17 inches. Sorry, from here to here. Okay, so we put in t equal to 0, that gets us started at 10. Moving forward till t equals 1, so we put in 1, and that makes our position 17. Okay. Then from 1 to 5, we move backwards, so we want to see what position we're at when t equals 5. I found that if you put in 5, you get out negative 15. Okay, so you would go straight back, but we're going to put a little space and then represent that we're walking back along that line. Okay, and we're going to go forward again till this stopping place when t equals 8. So when I put in 8, I got out 66. So we'll put a label. It's not quite accurate of a sketch, but over here we'll put 66. Have our bug come up a bit and walk straight forward till here. Okay, I think we could wrap it up. So this would be E, the displacement. Would be 66 and subtract 10 to get 56. The distance traveled. We take the distance from 10 to 17, add it with that other distance from 17 to negative 15, and then the distance from negative 15 to 66. So what I got was 7 plus 32 plus 81. It's equal to 120 inches. Yay, we made it to the end. And that's the end of class. So we still have a few more notes to do for section 3.7, and we'll